Hi, Frank from CircuitsFun, and today I'll be talking to you about the ultrasonic sensor. Before I start building this, I just want to talk to you about the different variations of these on the market. There are 3-pin versions of these which work the same way. The one I have right here is HCSR04, which is one of the most common ultrasonic sensors out there that a lot of people in the Arduino community use. I would recommend this one. It's quite cheap and also fairly accurate, but there are other variations. So the 3-pin version, it just doesn't have a separate trigger and echo pin, which I will go into in more detail later, but essentially they are the same as this. There are 5-pin variations of the ultrasonic sensor. The 5th pin just is an extra feature of that module. So there are some on the market where you can connect that 5th pin to an oscilloscope to see the ping signal that's getting sent by this sensor. And also there's one that uses serial communication that allows you to use serial communication with this sensor to see the values that it's producing. With that, I'm gonna start building this. So remember, with your ultrasonic sensor, don't connect it like this, which I have done in the past and wondered what's wrong. You need to keep it vertical because each row is electrically connected in a breadboard, which we might cover later. So here's the circuit to connect the ultrasonic sensor. You basically need to connect each pin to the Arduino. VCC goes to power, ground goes to ground. The trigger and echo pins can just go to any digital pin. So let me connect this to the Arduino now, to the computer now, and show you the code. I'll go through how the ultrasonic sensor actually works. If you can see here, there's a T on this side of the sensor, and that's sending a signal forwards. And what happens is, if there's an obstruction in the way, the signal will rebound from the obstruction and then be received at the other side of the sensor, which is labeled as R, which is the receiver. And that's how this sensor can actually work out the distance. It uses the speed of sound, the ultrasonic wave, and it can calculate how far the wave has traveled, and then you use the speed equals distance over time rule, rearrange that, and you can get the distance out. And that's this line right here. Pulse in is actually is what measures the time that it took for that signal to be received and sent and received. I'll show you in the serial port monitor now how this was working. Oh, I've already uploaded this code, that's why. But I'll re-upload it. Okay, so 44 centimeters, so there's something that's blocking there. I'll use a box to demonstrate. This ruler. Let's see how accurate this ultrasonic sensor is. I'll go to about 10 centimeters. And you can see it's pretty accurate. I can move this down to 9 centimeters. And it's 8, 9-ish, so perhaps the sensor, I need to move the ruler a little bit, it starts measuring a little bit further away. And you can see that it's quite accurate. If you want to get closer to, if you want to be very accurate and get to the nearest millimeter, let's say, that will cost you a bit more. Generally, with the prices of these ultrasonic sensors, it goes up as the accuracy increases. That's why this HC SRF4 is a lot cheaper than a lot of other modules. Generally, the HC SRF4 is appropriate for most prototyping. As you'll see on Arduino Hub, there are a ton of projects that use HC SRF4 and a lot of documentation too. So I really recommend it for beginners. So that's it for this video. I hope you enjoyed it. If you want us to cover more components, leave a comment. If you like this video and you want to see more, make sure you follow our social medias. You can visit our website at circuitsfun.com. We actually sell these components. And I think that's it. See you in the next video.